Join me, Harriet Gould, for the Lab Matters podcast to hear fascinating stories every week from the inspiring people behind the science. In this episode, we find out what gives Rob Adlard from Gravitilab sleepless nights. Hello, Charlie and Rob. Thank you very much for joining me today. Just to introduce you both, Charlie, you've got a background in aerospace, and
yes, that's right.
As well as in sales and in journalism, which doesn't necessarily seem like a natural match, but maybe it is. And you've also unbelievably got a master's in physics, so you've been fairly busy throughout. And Rob, before you launched Gravitilab, you had a background in materials science and did your postgrad in space engineering. And were involved in a number of highly technical positions at several space companies, and even published a report which explored the market for suborbital launch in the UK and Europe. And now you're both at Gravitilab. Rob, you're CEO, and Charlie, you're the science and data lead. And Rob, you obviously hit the nail on the head with that report that you wrote. And there is indeed a suborbital launch market. But I just, one thing I want to touch on first is that I think we tend to think of anything as space related as being relevant only to space exploration. But that's not the case. That you found the byproducts of space exploration are actually relevant in multiple different areas of research. Can you talk us through that realization and how you're making the most of that?
Well, I'll say a little bit about from sort of an engineering and kind of company perspective, and I'll let Charlie say much more interesting things about the sciencey side. So from a company perspective, I guess my background had been related to vehicles, and it's part of the whole thing of bringing space down to Earth. I was really excited by the idea that the UK was going to establish a launch market domestically in the UK. The idea that we could launch things to space from the UK was really, really exciting. So I got involved in that idea and supporting projects around that idea quite a while ago. And then I've spent a lot of time since we established Gravitilab telling people that we're not a rocket company. So being a pain to say, we're not a rocket company like Uber's not a taxi company. So, the founders of Uber weren't going around asking people to invest in a taxi firm. They're, of course, using space data to transform the way that transportation services are delivered. And so we're sort of using various bits of hardware and vehicles to transform the way that sort of research and testing services are delivered through our vehicles. So that's sort of one thing. And that was kind of what the report explored a bit. But then beyond that, I think that we would say that we are sort of providing some kind of upstream services for an enormous potential downstream world where these environments can just be used to advance scientific developments.
So yeah, absolutely. Building on what Rob says, let's first define what a microgravity environment might look like, because a lot of people will either just define that as being in space, or other people will recognize how that affects fundamental processes. So microgravity in general, if you're going beyond something called the Kármán line on Earth, where technically space might begin, there is a lot of debate around that, like what separates Earth atmosphere and in space. But generally in that environment, we have no buoyancy or a greatly reduced buoyancy, similarly reduced sedimentation, almost no convection. We have reduced hydrostatic pressure. We have a dominant surface tension effect. And we also have the realization of things like containerless fluids. So you can appreciate that in certain fundamental processes, mass transport is completely changed. And that can really help in certain research areas. Well, I actually struggle to think of many research areas that doesn't, sort of greatly influence things. So we tend to see gravity a little bit as noise or contaminant on Earth that actually masks or inhibits our understanding of these processes. And so by giving scientists access to these environments, not only are we allowing and advancing progress for space exploration, but we're also informing sort of core areas of research on Earth. And those can be anything from material sciences to cancer research.
Wow, it's just so extraordinary. I mean, to think that a zero gravity environment could help with cancer research? I mean, can you delve into that a little bit more? And
Absolutely.
How that actually affects the research on Earth?
So we're sitting here now, and every cell in our body knows what's happening. It knows that gravity's here, so they respond accordingly. But if you take a simple cell, like a T cell in cancer research, for example, take that out of gravity and see how it responds. For certain cells, and I'm not saying all, that it does vary from cell to cell, they can be a bit discombobulated. Biochemical events can change. You know, you remove gravity from the equation, remove the gravity receptor, sort of disorientate them, then it can affect things like cellular adhesion or proliferation. So that's why a lot of research on the ISS, for example, there's a lot of really big cancer research going into things from like brain cancer to gut and stomach cancer, because how gravity can affect microbiome reactions as well.
So, I mean, sorry if this is a ignorant sounding question, but why is that relevant? Because all of our cells are on Earth with gravity. So why is it important to know how they would respond without gravity, unless we were going to go space?
So for one example, it would be to develop medications that can perhaps achieve a similar effect. So help reduce the adhesion of a cancer cell to a human or like normal body cell, for example. If we can help achieve similar effects, then that will actually help increase the sort of ability to treat effectively on Earth.
Okay, right. Okay, that makes sense. Okay, well, fingers crossed that can happen then.
And then there is also, so a lot of the work that we do is about supporting other companies, other people's sort of research. So we're not really, you know, obviously we're not doing the research, we're providing the environments and the platforms to do that.
Yeah.
So there, you know, there are so many fantastic startups around the world, particularly in the UK, looking at these fantastic scientific challenges, the medical challenges. So there is a company thinking of Dr. Katie King and her startup who are looking at cancer treatments. And so the microgravity environment is required in order to be able to ultimately, hopefully, produce a treatment, a different way of delivering cancer drugs. And so there's a long sort of pathway to sort of development and testing in order to be able to reach that point. And so our services are about not just providing the environment which might then ultimately deliver the drug, but it's about sort of developing the processes and doing fundamental research, which is then going to lead to those really big breakthroughs. And then it might be somebody else's services, or it might be an orbital service, which then ultimately produces the drug. But all the work and the research up until that point is sort of where we come in. And so we're kind of supporting all these fantastic journeys along the way of all these other scientists and wonderful researchers who are doing these great things.
Yeah, absolutely. So actually, yeah, Rob, you raise a really good point. So Katie King of BioOrbit, you know, one thing that we're looking at through that is things like protein crystallization. So with protein crystallization on Earth, some proteins are very difficult to crystallize and then assess via like X-ray crystallography methods to establish their structures. However, in microgravity, because you've got the lack of sedimentation and buoyancy, actually you're allowing proteins to grow, crystals to grow larger and more uniformly in all directions. So that allows particularly tricky proteins like membrane proteins to actually be grown off Earth and studied. And that helps inform, particularly for genetic diseases such as muscular dystrophy, the actual treatments for that. So one example is the Japanese Space Agency. We actually have on Earth medical trials for Duchenne muscular dystrophy as a direct result of being able to grow the proteins that can help identify and, you know, inhibitors or triggering mechanisms for those diseases off Earth.
Wow. I mean, it's slightly mind-blowing hearing about it all, I have to admit. And that you're creating the environment for new breakthroughs is one thing, but really it seems to me that you've had this in itself is a breakthrough in enabling this type of research. And you've had a couple of genuine breakthroughs. You know, you were the first developer of industry-changing vehicles to achieve this. You know, no one else did it before you. One example is it's a UAV. This is unmanned aviation vehicle. Is that right?
Yes, It's so funny. These vehicles have all different kinds of names. Some people prefer to call them drones, and there's UAS, unmanned aerial systems. But I think we all sort of you get it. If you say a few of the names together, then everyone gets what we're talking about. So that is something which is quite unique. I mean, I would say we're sort of the first company to actually really focus on trying to provide these services as a comprehensive suite of services to enable all these industries. So people have looked at different bits of it. There have been suborbital rockets for quite a long time. If you want to talk about, not that we're a rocket company, but if you want to talk about the rockets, then there have been suborbital rockets around for a very long time. You know, they were the first types of rockets. And they were always seen as a development, a step on the way to somewhere else. But their sort of, purpose, what they do has kind of come back around and almost in a circle to meet, the kind of current technology needs. So what they do is they go into space for a period of time and they come back on a parabolic arc. Gravity eventually brings them back down. So what goes up goes down. It doesn't stay in orbit. And the benefit of that is that you physically get whatever you put in the rocket back. So you get the hardware or materials or whatever it is that you're testing physically back, which you don't when you put it in orbit. So that's sort of really, really useful. And so rather than it being something that doesn't achieve orbit, it's actually deliberately in order to get the stuff back that you're testing. That's really, really useful. So we're looking at sort of, completely different treatment of those kinds of vehicles for different purposes. I think we're the only company that's really looked at this and thought that we would try to address this kind of market, which has been disparate, and it's chunks of so many different bits of markets. That's one of the things that's sort of difficult for people to understand, is it's new in that it doesn't really hang together as a whole market yet, but it's not new at all in that it's using sort of bits of technology that have been used before in the past, and it's all the kinds of markets that we're familiar with, such as pharma, bio, material science, all those kinds of things. But the UAV system is really quite new, so I'll talk about that for a moment if I can. And that's so it's a patent pending system. And it's the first time, I think, in a very, very long time, anybody come up with a new way to really sort of access microgravity environments. It's slightly counterintuitive in a way, in that it's two vehicles that are both sort of UAVs or drone vehicles. One lifts the other, then it releases the second vehicle, which then powers itself down towards the ground. So that sounds really simple, and it is sort of relatively simple in a way, but there's obviously a great deal of development in there, and a great deal of, there's sort of all kinds of really boring challenges, like licensing challenges, because people don't like the idea of a vehicle powering itself down towards the ground. And there's no legislation really to sort of particularly, allow that. Nobody's really done it before. We're the only people who need to do that kind of thing. So there've been lots of challenges to solve. The benefit of that is that it's a very flexible way to provide access to these environments, and that's sort of what we're all about. So it's the accessibility. So you could, in theory, access microgravity environments before, but they're either very expensive. So part of the accessibility is bringing the cost down, but then it's about the sort of logistics of it. So do you have to travel 1,000 miles to a very specialist facility? Do you have to access that? And the answer is yes. So you have to access it through an institutional program that you have to be accepted upon. So your research has to be the right kind of research that ticks various boxes to be able to do that. So if you have a startup and you have a great idea and it doesn't, it's your idea, it doesn't align with the research goals of an institution, then you're not going to be able to access those services at all. So we're part of this kind of new space world. We call it new space. That just means providing commercial services where previously there've either been none or it's been dominated by governments and big international organizations. So this system, we call it LUI. It's the most flexible way to access microgravity. So it's a very short duration, so it's just a few seconds, but it's comparable with using a drop tower, which might provide sort of between 2 or 4 seconds. So it's a sort of slightly longer duration than a drop tower, but it's more consistent quality than a parabolic flight, which is another way of accessing microgravity from a terrestrial standpoint.
And how long? You're saying these 3 or 4 seconds, it sounds like such a tiny amount of time, but it's better than the other option.
Well, it's better, and it's much more accessible. So with our system, we can take it and we can deploy it in at any kind of local airfield initially, and then some of the testing that we're doing and approvals we've got from the CAA now is for us to just fly it on any kind of private land. So if there's a field that's an appropriate size, we can go and do it somewhere. So we can take it around the UK, we can take it up to Scotland to help researchers there. We can, so it's all about the accessibility, but it's all about, but it's also providing a consistent quality. So it's the same quality for the duration of the drop, which will be between sort of 4 and 10 seconds, depending on the configuration. And the point of that is it's a stepping stone, again, then to accessing minutes of microgravity. And it's an appropriate service at an early stage for somebody to just de-risk something that they're doing, or to answer a question, or to validate some modeling. And as I say, it's comparable in some ways with some of the services which exist, like a drop tower, a parabolic flight, but those things are much more difficult to access. And all you have to do, just picture a really big passenger airline. That's what we're competing with a very, very small system, which will fit in my hand. So you know, immediately, intuitively, you understand that it's a much more simple thing to be able to deliver.
But there's also other types of experiments that may not be sort of biomedical or biological that fit really nicely in seconds. Look at a simple combustion reaction, for example, or a quantum experiment that on Earth may actually be conducted within milliseconds. But actually, by then extending that to seconds, you're actually getting a lot more time to an opportunity to study something. So it's really quite a unique environment for those types of reactions as well in experiments.
And the other thing is that because it's all about sort of the control system of the vehicle, about how it accelerates. So it's accelerating, you know, at kind of 1G. So the stuff inside the vehicle experiences the inverse of that. So we can accelerate it so that it's simulating a lunar gravity profile or a Martian gravity profile. And those things are really, really important because mechanisms behaved completely differently. There's a famous instance of a NASA mission and a drill on Mars that didn't really work because the Martian gravity hadn't been taken into account. So there are all kinds of applications with in situ resource utilization for the Moon and Mars, where these, you know, very sort of low technology readiness levels need to be sort of de-risked through this kind of activity.
And one last example, again, say you've got something that you want to just be able to switch on once it reaches a planet or reaches space. You just need that second to verify that switch on is going to actually happen. Hence, another good use for Louis.
Yeah, Louis does sound incredibly useful. He's earning his keep. And you've got another well, and you say you're not a rocket company, but you have actually got a rocket delightfully named Isaac.
Yes, we do. Not an old Testament reference. So yes, so with our rocket technology, so we're developing. So we have the largest hybrid rocket engine test facility in the UK here, where we're based in Norfolk, and we're developing sort of scalable technologies which will enable us to do whatever we want to do with future services as well. But the first port of call is a vehicle called Isaac, which will provide minutes of microgravity with our suborbital flight, and then that technology can scale to provide bigger vehicles, longer durations, and then ultimately access new markets which we think are really interesting, such as VLEO, which just means very low Earth orbit. And that's
how low is very low Earth orbit?
It's really low. So it's shockingly low. So anywhere between 120 kilometers and 300 kilometers. So our suborbital vehicles, yeah. So suborbital vehicles go higher than that, or can go higher than that. So in that orbital plane, the spacecraft, we say spacecraft in spacey terms, what we mean is like that's the satellite or something, the bit that stays in space. The launch vehicle is the bit that goes into space and comes back and delivers the spacecraft. So the spacecraft, the satellite, whatever it is, then needs to be under constant propulsion in order to stay there. But the reason why it's of interest to people is that it's extremely a very sustainable way of using orbit. So once the spacecraft is not under propulsion, it will just deorbit because there's sufficient there's some atmospheric effects at that level, although very slight, but so it will deorbit itself. It won't stay there, and so you are mitigating space debris without having to go and clean it up. Nothing will stay there, so it's very, very clean, and it means that you're getting a better fidelity of readings from whatever instrumentation you have, and it requires less power. So there are all kinds of sort of positives for using that orbit. So we plan to be addressing that in terms of being able to provide longer durations of microgravity. So that could be months of microgravity for a passive system or years for an active system. And so there's some really exciting opportunities there for us too.
You're here with me, Harriet Gould, for the Lab Matters podcast. If you like what you hear, please rate us on your favourite podcast platform. It does sound like it. And just on that deorbiting, it just delivers itself back to Earth. So in the right place, it's not gonna.
It entirely depends. So there are ways of doing it so that yes, it will be in an exact place, or it will just be in a safe place, or So at the moment, when things return to Earth, rockets and things return to Earth, they're generally there's a particular spot in the Pacific Ocean.
Yes.
But that's not really ideal. So it'd be nicer for them to come back and be used, or for them to burn up and not produce, not actually have any sort of debris. So there are various different ways of doing it.
Okay. And at the moment, you're well, recently at least, you've done a collaboration with a UK university. We can't say which one. Is that right?
I think we probably can.
We can.
Yeah.
It was the University of Manchester. Yes.
And that was on the materials science-based research. Do you want to talk a little bit about that collaboration?
Well, I'll talk about what I know about it before Rob takes over, because it slightly preceded me joining, but it was essentially working with high entropic materials, and I think sort of trying to work out how to use disorder to the advantage of a material like development process. I'm not entirely sure. But yes, Rob, carry on.
Yeah, well, I'm not going to talk in scientific terms about it, but the project was, it's relating to, new semiconductors, I think, in terms of kind of the materials aspect, and there's a great deal of interest in that for all kinds of reasons. We would have to schedule another hour to talk about why, but probably lots of your listeners will understand why immediately. And so the University of Manchester has this incredible material science department. It's really quite large, and there are lots of researchers doing incredible things there. And obviously it's the home of graphene, that's just one bit of it. So there's lots of material science research going on there. They've done some incredible things in the lab, and they wanted to be able to repeat that in microgravity. So the interesting bit for us, and this relates very much to our services, is that in order to do that, we have to create a new module for them, which will heat up this material in a short enough period of time for it to experience microgravity, get hot enough, and go through this transformation. So that doesn't exist. So that's sort of bespoke work that we have to do. Now that's work that we're really happy and excited to do for any customer. So if they have something which is unique and just doesn't exist, then we can work with them to realize that payload, manifest it. But it's something that's sort of very much at the core of our sort of services, thinking about, so let's forget about rockets. It's going to bring it more down to earth. We want to create various kind of lab modules. So, we're Gravitilab, and we want to be able to have these lab modules, which we can place in the right environments. So if you need a microgravity environment or something that's, that's taking advantage of these sort of absences of buoyancy and sedimentation, etc., so we can create the module for that. And so it might be a bioreactor, it might be to test material science, it might be to what kinds of other things. Well,
for example, like with a quantum experiment, and sort of atomic interferometer is one sort of far out idea I'd have, to utilize ultra cold atoms. That's a very sort of simple way of describing that experiment. But yes, or a bioreactor, for example, to do a biomedical or biological experiment.
So the thing is that so when our customers want to advance their research, they don't need to know about the rocket. We don't have to look at the rocket or talk about the rocket, but they can have a list of these modules they can look at and assess whether their research is going to fit in one of them. And if it doesn't, that's fantastic. So they're just going to put it in there, and we're going to do that for them. If not, and it's really is worthwhile research, then we can develop that module for them, and then maybe that goes on to have a life of its own after that, or maybe it's just for that research. But that's the service element that we're really seeking to provide.
It certainly sounds like it's going to be really well used. I hope it is, at least anyway. And just to track back a little bit, I think just to put it into context, or just out of general interest, I just wondered what motivated you initially towards space per se, or space engineering in the first place? Was it a gravity thing? Was it a space? What was it that triggered you?
I mean, there are so many different things. I mean, I think there are so many different geeky answers I could give to this, really. I don't know if any of them are of interest. I would say that, I mean, gravity is so utterly fascinating. If I sort of did my life again, I might want to spend more time in physics rather than applied bits of physics and really do some research. I think it is utterly fascinating. And that's not really kind of what we're talking about, actually, is what gravity is. We're just talking about these sort of, environmental effects and what they mean for, the sort of basically the equations which govern the behavior of all these other things. So that's fascinating. I've always been fascinated with vehicles, with robotics, with instrumentation. And I think for a lot of people, I mean, we've got a fantastic group of engineers here and our kind of rapidly growing team. And they all choose space engineering, I think, because it's the sharpest edge of everything, so the demands of space. And also, gravity on our planet is really it's quite extreme. It's not nothing, it's not Jupiter, but for an inhabitable planet, it's really quite, I would say, probably quite high level. No, we don't really have a fantastic way to benchmark this, but it's pretty much at the limits of chemical propulsion to be able to escape Earth's, Earth orbit and move on to another planet. So it's kind of at the level. If it was much higher, then we would have had to have developed, some kind of nuclear or nuclear propulsion rather than chemical. So we're quite lucky we can just do it. It's really quite exciting, and so because of that, everything has to be so optimized, has to be so well designed. And I think that's what draws engineers into this field.
Yeah, I think we sometimes, go through life not really thinking about gravity, unless you maybe watch The Big Bang Theory or something. But it's nice. It's nice. It's fascinating to hear how utterly inspired so many people are by its very existence.
It's pretty cool. Yeah, and I was just say, I mean, it's again really geeky, silly comment, really. But when you start thinking about gravity, it kind of you go through a period where it sort of dominates. I think your thoughts for quite a while. You realize that everything in your life is absolutely dominated by gravity. The way that your body grows, everything you do, the way everything works, the way that things happen to you, the things you see, everything is affected by gravity. You're experiencing something on a day-to-day basis, which is really quite a strange force of the universe.
Absolutely. But I mean, gravity itself has been a huge headache in many ways for scientists, really, since it's sort of the consciousness of gravity began, because we're still unable to unify a quantum friendly theory of gravity with classical physics. So again, if we were to go into a very nerdy interpretation of why microgravity is useful, it allows scientists to conduct fundamental tests removing gravity that actually may then help us understand how to sort of marry those from the quantum mechanical side of things to the classical physics side of things, which has been inherently very awkward for the last 100 years or so.
Indeed it has. And there was you've got another, did we talk about Louis? Did we talk about the Cornwall drop with him? We spoke about Louis earlier, but we didn't mention the Cornwall drop.
No, so that was one of the, so it's kind of interesting.
Yeah. The Cornwall drop. We know what a drop is now. We're going to zero gravity environment in that.
That's right. So that was the first time that we sort of dropped the drop pod. We call it the drop pod, but that's the sort of Louis bit, the exciting bit. So the ascent vehicle which lifts Louis is an ordinary looking drone in a way. It's a big one, but people who like drones would be excited about it, but it's just a vehicle which lifts it. And then the exciting bit is the Louis bit, which gets dropped and then powers itself. So harking back to the challenges with the regulation and legislation and the CAA, regulating these new areas, like spaceflight's a new area that the CAA is regulating. And there are lots of, things to do with UAVs, which are relatively new where they're finding ways to regulate as well. So yes, they were pretty nervous about it. And so the initial requirement was that we do it somewhere exceedingly safe. So we went to a specific danger area, Cornwall, and somewhere called the Lizard Range down there, which is, it has civil usages, but it was, I think, originally certainly a military site, and there are still some military applications that go on there. And it's somewhere that we're probably going to return to because it's one of the few places in the UK where you can do research and testing with beyond visual line of sight operations. And so our aspiration to provide longer durations, longer seconds, more seconds of microgravity is to drop it from higher altitude, and a sufficiently high altitude that it is then literally out of your visual sight.
Mm-hmm.
So although we didn't do that on these initial drops, that's where we had to go to do these first drops in a very, very safe place. And then moving on from that, we're then able to do it from smaller bits of land and areas which are not specific danger areas. So there's a bit of a process to do that. So we'll be going back to Cornwall to do more of that, in the future.
Sounds exciting. So you've created this new service now. It's all unified. You've effectively unified a fragmented market for making things really accessible. And how are people going to know about you, I suppose, is the question. Like, how do they know now, A, that they need this type of support in the research that they're doing, and B, that they can go to you to get that?
Well, I mean, that's definitely one of my core focuses, is particularly engaging with the academic community, just to raise the awareness and really tune people back into doing microgravity research. Because I think, as Rob's already highlighted, there's these legacy programs that potentially, it's brilliant that they've existed, but it's potentially inhibited or stymied progress in certain research areas, because there's this huge timeline where you may have to plan an experiment, it may or may not get accepted, and then it may or may not work once it eventually reaches orbit. So it's really about engaging with any researchers that wish to do an experiment in microgravity, whether that's to do with materials manufacturing, 3D printing, a chemist, or a physical chemist, or a biological scientist who's never actually, used microgravity before. So for us, we can engage on grants, so to help, realize a new research project. But also, as Rob said, we want to develop these containers that allow someone to put a biological sample in, or a certain type of material or gas or liquid, and conduct experiments that we will actually customize the payload containers to help them do, whether that be a thermal experiment or a quantum experiment, or trying to 3D print a biocomposite using a new fiber and then test its mechanical properties. We can potentially create payload containers that help facilitate that.
Well, that's a really good question, though, Harriet. Sorry, I was just going to say that's kind of at the heart of it. You hit on something which keeps me awake at night, which is how we could communicate this, because it is this fragmented market, and there are various ways of framing that. And I would say that there was a time that I went to a conference that was about microgravity research, and it was a space conference, and it was part of the big institutional world. And I did a talk, and I talked about companies that we've been talking to. And afterwards, somebody said, I just don't get it. Well, they're not space companies. You're not talking about space companies. Why? What's the relevance of this? They just thought that was an anathema, and that was a strange thing. Whereas for me, that's the whole point. That these aren't space companies. These are people who want to solve kind of everyday problems. And also, we don't care if it's not. It doesn't have. It sounds wonderful to talk about new medicines for cancers, and that's probably one of the best things about it. But we also spoke to a chocolate manufacturer who wants to understand better how bubbles are forming in their chocolate. There are all kinds of things it could be. And I feel like our challenge with this, as you say, drawing together a sort of fragmented market, is possibly what people went through, in the 1980s, when people were trying to understand the new world of Earth observation. Now, today, if you're trying to sell an application or a product or raise funds for that kind of activity, you don't have to explain to people the value of the fact that we're measuring the change in polar ice through Earth observation. We're taking climate change readings. We're doing all kinds of stuff with communications. We're observing all kinds of things about the Earth, and we rely on that every day. And your phone is utilizing that data all the time. You don't have to explain it now, but at one time, people would probably just thought you were crazy if you said, right, I'm going to put this spacecraft in orbit and I'm going to sell all this data to people who don't even know, don't know what a spacecraft is. And so we're in a similar situation. We want to be able to tell people, in all walks of life, who don't know about this at all. And in my experience, researchers are very open-minded about new methods and doing new things. And if researchers aren't creative, they're probably not going to get very far. They have to be extremely creative about what they do with limited budgets, and about how they can get around things that they can't really physically test, how they can simulate things, how they can model things. And so people are sort of getting around this now in a way which isn't great. And if you could present them with this opportunity, I think they'll bite your hand off to be able to do it in that way and really get their research into that environment. We just need to be able to access platforms to be able to tell people, who aren't connected with this world at all, about this opportunity.
Yeah, exactly. Well, hopefully this might help a little bit, and a few people will hear this and think, gosh, yes, we'll get in touch with Gravitilab.
I mean, I think, sorry.
Carry on, you go.
Yeah. I was going to say, I mean, there's a couple of mechanisms that we're coming up with to help facilitate raising this awareness as well. We will be looking to develop national calls for microgravity experiments to actually really sort of ring the bell for researchers to come to us with their ideas, and we can work out ways that we can work together with them to develop either our payload containers or help realize their experiments within a payload. But another way that we're going to be doing this shortly is via a national student competition as well. So actually engaging researchers early in their careers, as sort of postgraduates or undergraduates, to sort of compete to win time on our Louis drop pod as well. So it will help sort of just invigorate and sort of help encourage that sort of early awareness.
Certainly. And where can people go to find out when that competition is launching?
Please do keep an eye on our website, because we'll clearly have a sort of web page with all the information on the competition when it launches. Yeah, so hopefully that will be in the next month or so. But just watch this space.
Watch this space, and it'll be gravitilab.space.
That's right. Yeah.
Gravitilab.space, and then look out for the competition. I think you're right. I think bringing people's awareness levels up when they're young helps enormously, but hopefully we can do that with everyone, because we're all really young in the great scheme of things, I hope. Well, look, it sounds so fascinating. I'm so pleased you've come and talked about it today. Thank you again for joining us, and hopefully we'll hear a lot more about you and the impact that you're having in the future.
Great. Thanks so much, Harriet.
Thank you.
Thank you.